Hello guys, I am Munot and welcome to the School of Physics, and today we are going to do part 4 of modern physics. Okay, so today we are going to do the atom. The atom. This is the most important part of modern physics. Part 4 of modern physics. Modern physics. Okay, this is the most important part of modern physics. All we need to do is remember some formulas. I'll tell you the meaning of those formulas. First of all, let us see what are the lines. So inside an atom there are lines which we name as, so suppose we name here n is equal to 1. This is Lyman. Okay, then n is equal to 2. Okay, this is Balmer. Then Paschen, n is equal to 3. Paschen, Lyman, Balmer, Paschen, bracket, n is equal to 4. Similarly, Piffend and Humphrey, n is equal to 5. Piffend. So these are the lines inside an atom. Okay, so what happens is that suppose I'm telling you the first formula, which is based on the Rydberg constant. So I'll tell you what Rydberg constant is. Rydberg constant is 1.1 into 10 to the power minus 7, or sorry, 10 to the power plus 7 meter inverse. This is called Rydberg constant. Okay, Z is the atomic number. Okay, and what is an Armstrong in meters? Armstrong in meters is 10 to the power minus 10 meter, and in nanometer. Okay, so nanometer, 1 nanometer is equal to 10 to the power minus 9 meter. You have to remember this because these will come in exams. So what happens is, if an electron jumps from say n1 to n2, okay, any n1 to any n2, then the wavelength 1 by lambda is equal to RH, which is the Rydberg constant, into Z square, that is which atom it is, atomic number of the atom, 1 by n1 square minus 1 by n2 square. So this is the formula, Rydberg formula. Okay, now the next thing that I'm going to tell you is what is the value of Hc. Okay, so value of Hc, you should remember this directly. Hc Verma is 12 number का 420 electron volt meter. Okay, Hc Verma 12 number का 420. You can remember like this, 12 number का 420 Hc Verma. Or you can also have this in SI units. We know 1 electron volt is equal to 1.6 into 10 to the power minus 19, 1.6 into 10 to the power minus 19 joules. So we can write this in electron volts. This is 2 into 10 to the power 25. This is in SI units, 2 into 10 to the power 25. And we can also have this directly, this value directly, Hc by E, where 1 E is equal to 1.6 into 10 to the power minus 19. That is the charge on electrons. So Hc by E is 1.25 into 10 to the power minus 6. 1.25 into 10 to the power minus 6, and this is not 2 into 10 to the power minus 25. This is 2 into this is not 2 into 10 to the power plus 25. This is 2 into 10 to the power minus 25. Since H is 6.634 into 10 to the power minus 34, and C is 3 into 10 to the power 8. Okay, so where will this be used? So this will be used in finding lambda minimum is equal to Hc by E into voltage, as we have seen in the photoelectric effect. So this will be used as 1.25 into 10 to the power minus 6 upon V, voltage maximum. Okay, voltage maximum. Okay, so write this down. The next thing that we are going to do is we are going to find out the formulas for radius, energy, frequency, and we are not going to do it like we are not going to learn the full formulas, we are going to learn the directly applicable formulas. All the things I have calculated already, I'll just give you the direct numbers and you have to remember them. So the energy, radius, Bohr radius, energy, frequency, then time period, which is obviously the reciprocal of frequency, then velocity. Okay, so I'm just going to give you formulas which you have never seen before, and if you apply them directly in the exam, that would be just a matter of 2 seconds within which you will get the answers. Okay, so I'll just do it in 1 minute. I hope you have written this. Now I'm going to tell you the formulas for radius. So start, let's begin. This is the radius. Radius is equal to 0.529 into n square by z Armstrong. Formula number 1. Formula number 2. Okay, formula number 2, velocity is equal to 2 into 10 to the power 6 z by n. Remember, this is n square by z, this is z by n meter per second. Okay, then we have to remember energy. Energy is equal to minus 13.6. We'll just do square of z because you know energy is mv square. Okay, half mv square, so we'll just do so minus 13.6 z square by n square electron volt, or in terms of joules, this is 2.18 into 10 to the power minus 18 n square by z square joules. Okay, the next thing that we are going to do is number 4th, energy, then frequency. Frequency is 6.51 into 10 to the power 15. We'll add an n over here, z square by n cube hertz. Okay, and then the time period. For the time period, we'll do 1 by frequency, and that 1 by frequency would be 0.15 into 10 to the power minus 15 n cube by z square seconds. Okay, so these are the formulas you have to remember directly. And so the mass of electron has already been included in calculating these numbers, mass of electron. But if I tell you what is the proportionality of these things with mass, so radius is directly inversely proportional to mass, and so is the time period. Okay, velocity does not depend on mass, okay, does not depend on mass. Okay, and energy is directly proportional to mass, so is the frequency, and time period is inversely proportional to mass of the electron. Okay, so the thing that we are going to see is, radius and time period both are inversely proportional to mass, and both have n in the numerator and z in the denominator. So this is n square by z. Then velocity, energy and frequency have z by n. So you can remember like this. So v is directly proportional to z by n, e is directly proportional to z square by n square because we have half mv square, and for frequency we add another n, so frequency is directly proportional to z square by n cube, and time period is obvious, it is n cube by z square. Okay, the next thing that we are going to see here is we have done the Rydberg constant. We know the energy in different states. Okay, so since we have talked about energy, this is the thing that is important and I don't want to leave it out. So this is energy in different states. So here for a hydrogen atom, Z is equal to 1, and in N is equal to 1, the energy is minus 13.6 electron volt. Okay, you have to remember this directly this question can come, minus 13.6, then we have minus 3.4, then minus 1.5, then minus 0.85. electron volts. So why am I telling this? It's because the energy will be given directly. The energy will be given directly, that either it is minus 0.85, minus 0.15, minus 3.14 and or minus 13.6 will be the energy given in an orbital. Now what happens is you have to directly use the guess the which series is this, guess the n. So if it is n minus 3.4, we can directly say it is n is equal to 2, that is Balmer. Okay, so this is how we have to use this. So also there's one more unit of energy, 1 erg. 1 erg is equal to 10 to the power minus 7 joule, or say 1 joule is equal to 10 to the power 7 erg. 1 joule is equal to 10 to the power 7 erg, or 1 erg is equal to 10 to the power minus 7 joule. So I think that's all about atom. And remember these formulas, very simple formula. And please subscribe to my channel so that I can make more videos like this. Thank you for coming to School of Physics.